All right, let's just jump right in. When you think about math, you probably picture this world of pure, clean logic, right? Numbers, formulas, all totally separate from the messy, chaotic story of human history. But what if that's just not the case at all?
I mean, is it really this untouchable realm of timeless truths discovered by some lone genius locked away in a quiet room, completely unaffected by what's happening right outside their window?
Or, and this is the really exciting idea, what if mathematics is actually a product of its time? What if it's a story of brilliant ideas that are sparked and shaped and totally fueled by the culture, the politics, and even the art of their day? That's exactly what we're going to dig into.
Okay, so our first stop, the 16th century. We're talking the peak of the Renaissance. And this wasn't just a rebirth of art, It was a moment of huge change in how people even thought about numbers.
So let's meet our guy, Francois Viet. He's a mathematician, and he's living right in the middle of this absolute cultural explosion. Seriously, he's working at the exact same time as giants like Leonardo da Vinci, Shakespeare, and Galileo. He's not in some lonely tower. He's breathing the exact same air of discovery as everyone else.
Just think about that parallel energy for a second. While artists were completely reinventing perspective and explorers were literally redrawing the map of the known world, Viet was doing something just as revolutionary. He was redesigning the language of mathematics. These things weren't happening in isolation. They were all part of the same human drive to see the world in a brand new way.
You gotta understand, before Viet, algebra was, it was a mess. Problems were written out in these long, clunky sentences. His stroke of genius was this incredibly powerful idea: let's use letters to stand in for numbers. Vowels for the things we don't know, and consonants for the things we do. And bam! Suddenly, math has a universal language. You can create general formulas that solve whole categories of problems, not just one. He basically gave us a whole new way to think.
And this new algebra? It wasn't just a party trick for academics. Get this, during a war with Spain, Viet used his new math to crack a super complex Spanish code, giving France a massive upper hand. The code was so tough that the Spanish king, Philip II, just couldn't believe it was done with math. No way. He was so convinced he actually accused Viet of using magic and complained to the Pope that France was in a league with the devil. That's how powerful this new math was.
And believe me, this pattern isn't a one-off. Let's fast forward a bit to the 18th and 19th centuries. This is the age of revolution, political, industrial, you name it. And just as society started to question the absolute power of kings, mathematicians started to question the absolute truths of geometry.
I mean, this was a time of incredible upheaval. You had the Enlightenment, which put reason above old dogma. You had the French Revolution, which completely turned the social order on its head. And then the Industrial Revolution was physically changing the entire world. Everything, and I mean everything, was up for debate.
Now, for more than 2,000 years, one system of geometry ruled them all: Euclid's. Its basic rules, its axioms, like the idea that parallel lines never ever meet, they weren't just seen as good ideas. They were seen as unshakable, absolute truths about the way space itself worked.
But what happens when that revolutionary spirit is in the air, right? If you can question the divine right of a king to rule, why on earth can't you question an axiom from some ancient Greek textbook? And that is exactly what started to happen. This led mathematicians like Giovanni Saccheri to start playing this incredible what-if game. They started to imagine these strange new worlds where Euclid's rules didn't apply. Now, the funny thing is, he was actually trying to prove that these other worlds were ridiculous and impossible. But in doing so, he accidentally unlocked the door to entirely new types of geometry.
And this is where things get really cool. It gave us non-Euclidean geometries. So on a flat surface, that's normal Euclidean geometry, a triangle's angles add up to 180 degrees. Simple. But on a curved, saddle-shaped surface, that's hyperbolic geometry, they add up to less than 180. And on a sphere, which is elliptic geometry, they add up to more than 180. And get this, parallel lines don't even exist. They always eventually cross.
Okay, so we've got two huge moments in history. One in the Renaissance, one in the Age of Revolution. Both times, math takes this giant leap forward. So,
What's the hidden pattern here? What's connecting them?
The big breakthroughs from Viet and later from guys like Lobachevsky with these new geometries, these ideas didn't just appear out of thin air. They weren't isolated sparks. They were totally plugged into the world around them. The questions they were asking in math were the very same kinds of questions people were asking in art and politics everywhere.
So it turns out there's actually a model for this, a kind of blueprint for how great ideas come to be. They aren't just random flashes of brilliance. They are born at this very specific intersection, a meeting point of a person, their historical moment, and the network of thinkers around them. It's not magic. It's a system.
And it really just boils down to 4 key things. First, you need the person, someone with that brilliant, unique way of seeing things. Second, you need the time. That's the culture, the politics, the whole vibe of the era. Third, you've got the specific idea, the breakthrough itself. And finally, number 4, you need the connections. That whole network of thinkers, past and present, that creates the conversation.
So this totally flips our idea of genius on its head. It's not about a lone person getting struck by a lightning bolt of inspiration. It's about a connected mind being powered by its unique moment in history, a mind in the right place at the right time.
So what? Why does looking at math this way even matter? Why should we care that there's a human story behind all the numbers?
Well, it pretty much changes everything. For one, it totally busts that myth of the isolated genius. It makes these really abstract concepts feel so much more human and accessible. Because when you see the context, you suddenly realize that an equation isn't just some cold, dead formula. It's the last sentence in a thrilling story of discovery, a story that we can all connect with.
So, from now on, the next time you look at an equation, just pause for a second. Try not to see just the numbers and the symbols on the page. See the story that's hidden inside it. A story about real people, the incredible times they lived in, and the brilliant connections that made it all happen.
Because every great idea, whether it's in math or art or science, has a story. And really understanding that story is the key to understanding the idea itself. So my question for you is, what great idea will you look at differently now?